I'm Krzysiek Taperek, and I will try to tell you how we achieved quite okay working UI in Frostpunk 2. That's the best I can tell. I will mostly tell you how we went from this version, which was the first prototype on Unreal made 3 years ago, to this version, which was released a month ago. But it's the postmortem for the whole project, so I can't skip the beginnings, the less known part of the story, which was the version of our game on Liquid Engine 2. So to give you the more context, Frostpunk 1 was made on our custom in-house engine named Liquid Engine, and we could always just go to the author of the code, ask for help, and it was working quite well. Of course, we didn't have that much support because they have always more important things, but it was in-house and it was always a possibility to ask for help. So on our custom engine, everything was XML based, mostly data driven, so it was possible to merge stuff there. And of course, it wasn't that easy, but it was possible to edit everything manually from the text editor. And everything was based on entity component system. It's the architecture where actors or entities are just containers for components. Components contain all data, and subsystems or systems are responsible for handling the whole logic. So they get data from components and then operate on that and modify state of components. For me, it started in 2017 when I joined as junior gameplay programmer. It really was the UI programmer work, because no one told me that no one wants to make UI, so they made me responsible for that. When I joined, this is the screen from the demo from the end of 2016. Everything was in theory in place. Okay, maybe not everything, because Book of Laws, which is the very beautiful panel with tree-like structure, looked like this, so there was 2 entries and that's all. But there was a lot of stuff done already when I joined, but everything was updated on tick, everything was recreated all the time, and it was not sustainable. So to achieve this version, we had to refactor almost everything. So there was a lot of work with that, but after that we moved to console version, and the rest of the team was focusing on DLCs. We learned a lot from creating that UI on our beautiful Liquid engine, and that's why I was really eager to work on new project to set up things correctly for once. So it was time for a new project with new ideas, but quite old problems. We moved to Liquid Engine 2, which was the new beautiful version of our engine. And the engine team was worked quite hard on that for a few years probably. And plans were really ambitious. We had a lot of custom tool sets, a lot of custom editors, node-based. We had our own visual scripting. But for me, the most important thing was UI ECS. For the first time, UI was based on ECS, so the same architecture as the rest of the game. And it was really beautiful. That was a cool idea. I really had to implement something like that. So that was the UI editor in Liquid Engine 2. But of course, as every custom tech, basically as every tech, it had a lot of own problems. So that's how our editor worked. Here we have gizmos, so everything was flying around all the time. So it was quite clear that our engine was not ready for the whole team. And that was our UI artist reaction when he saw for the first time our Liquid Engine 2. Because it was even worse for him than Liquid Engine 1, and it wasn't great in that time already for artists. So engine team with small Strike team moved to implementing base stuff for the game on Liquid 2, but the rest moved to prototyping on Unity. So we introduced another engine. Most of designers, gameplay programmers, artists moved to Unity. They were testing mechanics and prototyping them. We were trying to keep up on Liquid engine with the game, with all mechanics that Unity team accepted, tested. So that was the state of the game on Liquid at the end of 2020. And that was really hard because we didn't have enough people for that. And basically it was really pain in the ass, but okay. After some time it started looking quite okay. UI ECS was really evolving. That was really something for us. So it was promising. We implemented more tools. Logic for those panels here had even some blueprint-like implementation in our own visual scripting. So it was progressing quite nicely. And that was the last demo on Liquid, and this talk would be totally different about the beautiful new approach to creating UI, but unfortunately for me, we switched to Unreal. So, now what? From the tech perspective, it was starting all over again, everything. And it was quite problematic because the gameplay team advanced with ideas on prototypes in Unity when we were working on Liquid. And the top priority for us was unlocking the whole team. They should start working on the proper game, not some prototypes. So we didn't have much time for preparations for any real structure. So we were rushing just to unlock possibility to create assets, work on our already approved mechanics, etc. So it was really difficult from the tech side, but the Frostpunk 2 is much different from Frostpunk 1, mostly on the gameplay side, on narrative side, because scale changed a lot. Instead of 789 people in Frostpunk 1 because it was crashing for more, so that was the cap for population in the first game. And now we have tens of thousands of people, and the scale is totally different. But UI-wise, it wasn't that bad. A lot of change, mostly the art style, but the scope was kind of the same. So, for example, in Frostpunk 1 on the left, we had few dozens of buildings with selection panels and some trackers, so small UIs displaying some state, versus Frostpunk 2, where we have few dozens of districts with selection panel and trackers, or panels on Frostend, so our world map. We had some selection panel for that with one big button, then we have exactly the same stuff in Frostpunk 2. Or our Book of Laws or idea tree. In Frostpunk 1 we had Book of Laws that was tree-like structured widget, and in Frostpunk 2 of course we have something very similar, which is now called idea tree. But the rules are quite the same. Or economy panel, which we don't have in Frostpunk 2. So even less scope, but we still have time for that because in Frostpunk 1 it was implemented after almost a year, so we still have time. Okay, so let's move to Unreal Engine implementation. With similar scope, we copied a lot of solutions from Frostpunk 1. It was the easiest way, the easiest approach, and we didn't know a lot about Unreal. We didn't hire anyone strictly with Unreal Engine knowledge, so we were going with the same team that was working on custom engine, so we liked custom solutions more. Let's talk about base game setup. Our new way in Unreal was still as close to ECS as possible, so we still tried to copy all solutions that were working for us in Frostpunk 1, but on Unreal, so we didn't want to fight with Unreal, but when possible, we were doing it the similar way. So still logic is mostly in subsystems, and we are using components and actors in a similar way. We are avoiding putting any logic in actors and components, but of course it's possible when needed, because sometimes it's just easier in Unreal for mostly visual stuff. What does it mean for UI? In UI we have only few subsystems, because of course we are using UMG, so we don't have components, so it's totally separate system from the total classic workflow for Unreal. So yeah, of course we have some exceptions, because trackers have components, so we have our custom component for that, but that's the only case here. So how we approach the management of that UI? In Liquid, in Frostpunk 1, we had single main screen, so that was one single widget, very, very big widget, that contains every widget in the game. That was, of course, in XML, so it was a few hundreds megabytes of XML. That was lovely to merge, but it was possible to merge at least. And all panels were implemented in the code. In Frostpunk 1, we didn't have any script language for that, any visual scripting, so everything was just put in the code. In Unreal UI, of course, it's difficult to me to talk about Unreal UI because we don't have much materials for UI in Unreal, but the most common approach is just adding widgets to viewport, and they dynamically add them and delete them, so the most important thing is to keep a small amount of widgets as possible, so we quite often see even baking some textures into single widget just to save few widgets, make less images on the Unreal side. So when we moved to Unreal, that was obvious that we will just go with the single main screen, which worked for us in Frostpunk 1. Probably it's not that reliable in Unreal, but we did that anyway, because we really like the direct control over the whole hierarchy. And most of panels we implemented in blueprints. Blueprints are really easy to implement stuff, a little worse for maintaining it later, but it's less important on that step. So we implemented most stuff in blueprints, and we moved only more advanced panels to the code. And that's the screen from our main screen in Frostpunk 2. Of course, I know it's not visible on the presentation, but I'm showing it anyway. So we have all widgets in the same place. Some of them are just hidden for editor only. And here we have around 50 or 60 widgets. And all of them, of course, are other widgets, and they are nested in another widget. And here we have whole hierarchy for whole game. So how optimize for memory? Of course, it's terrible. It's not the Unreal way. We shouldn't do that because we should keep as low amount of widgets as possible. But we did that anyway. And here are some numbers, how many widgets we have at the same time. So we have 7,000 widget 3, which is the base start for widgets. We have 15,000 canvases, 2 times more slots for canvases, 32,000 images, and the worst thing, more than 1,000 returnal boxes. About returnal boxes later, but it's very convenient tool to use because you can put material on widget, which is very nice and very expensive. Then why we did that? First of all, we really like the direct control over the hierarchy. So we had no problems with managing the hierarchy, with changing the order of widgets. Everything is in the same place, and it's very easy to change it. And we have a lot of translucent things. We have almost everything with blurs, so we can see panels under them, so we still need to render them, basically. The other important thing is loading everything once. So we don't have any popping widgets in a way visible to players because we just load them during the loading screen. So at least this part is better. Of course, we have some exceptions as usual, but as the general rule, we are loading everything at the start. It's just easier to debug and maintain. If we have some bug, we have single point where we are starting looking for things, and the whole configuration is in kind of one place because we have a lot of configuration in those panels available all the time. And it's better performance. It's counterintuitive, but as we tested, it was for us better because loading dynamically quite often killed the frame rate for us. After deleting widgets, we have quite expensive garbage collector, which is also causing some hiccups, and recreating widgets also use CPU time. So CPU-wise, it was better. Of course, nested hierarchy is not ideal because it has some overhead because we are calling, well, Slate is calling a lot of functions on the whole hierarchy, but it was still better performance-wise for us. And memory-wise, it was okay, maybe not great, but not terrible. We didn't have problem with RAM usually. Okay, so how we exactly approach to manage that? We have basically one subsystem for whole UI management. Sounds like a god-like object, but it's not really that bad. It's panels management subsystem. It manages panels. So it's a game instance subsystem, so it lives as long as the exe of the game, not world bound. And it contains list of all panels. So of course it's not ECS style architecture. It's not component system, but it behaves in similar way because we still have list of all objects of that type, and we can iterate over them, and we are managing them in this single place. And of course, our panels are heavily nested, so there is a lot of logic behind that to handle dependencies between them. Okay, so panels management subsystem manages panels. What is the panel? It's the base building block for UI. Basically, every single thing that is visible to player and depends on the gameplay is panel for us. So, for example, construction panel, some modal, but also some tracker could be a panel if we can change its visibility based on some gameplay. Of course, it contains some logic, like it's open from the start and stuff like that. But we are keeping it very simple. We are not trying to push everything to that single object. And it has one of the most important things. It has UI group. What is the UI group? A UI group is just a simple configuration for panels. A lot of multiple panels can have the same UI group, and every panel can have only one UI group. And in UI groups, we have some configuration like if it's exclusive. So if we have 5 panels, full screen panels in the same group and they are exclusive, when you open the new panel from that group, it will close others. And the most important thing here, we have contexts. Contexts are quite important here, and they're very simple, and obviously they allow to open only specific panels. They allow us to to approach that mechanics. And here, that is the simple context. It doesn't have a lot of configuration. Mainly, it has some inputs. We are bounding our inputs in enhanced version. Enhanced input is something that Unreal added in 5.1, I think, and we are using it. And we are bounding every shortcut in the game to context. That's the easiest approach, to block inputs by those contexts. This pause menu context, of course, is activated when we open the pause menu. But the more important thing is this version. So this one is a composite context. It contains a lot of more logic. It inherits from the simple context, and it contains set of rules. So this one can be active only when all of context from the first list is active, and none of context from the bottom list. So that's the way how we blocked the opening pause menu during cutscenes. We are blocking everything like that. So we are just putting context that are exclusive, that contains a list of rules, all of, any of, or none of, and that's basically it. We have handy tool for that, which is just a list of all contexts. We can open it in runtime, and we can automatically see which contexts are active, which are not. So it's very easy to debug it. And important distinction, on the left side there are simple contexts that we can switch just by clicking by this debug UI. And on the right side there are composite contexts, which are not possible to change manually. But we have tooltip with all rules what you need to achieve to activate that context or deactivate it. So for example, for tension ball, which is the widget at the bottom of the screen which displays tension, this context will be active and UI will be connected to that when all of context from the first is, so we are in the city and tension is available, are active, and when none of the contexts from the second list are active. So when we are not in colony, because colonies don't have tension, that's our mechanic in the game, and when we are not in any construction mode. Okay, so let's move to the last important building block for the UI. We have also base user widget. So when we are using panels, when we are using just user widgets, this is the base class for asset when you don't need to steer the visibility manually from the logic. So if you just want to create some reusable piece of widget, you are creating base user widget. You can use it for some backgrounds, some panels. Panel is not a good word here. For some generic usage widgets. They don't have any UI groups, any context. They don't have any logic. We are trying to not put any logic in them. They should be kept as simple as possible and just easy to reuse in multiple places. So let's see example widget. Here we have top center HUD. It's quite a big one. Probably it's a few thousand widgets in total, but we don't care about that. On the left side we see hierarchy. So even in the single widget we have around 30 other widgets, and a lot of them are of course nested. For example, this panel, PX city status panel, is implemented in the code almost entirely because it was just easier. In Blueprint we are implementing only the visual part of the logic, and there is a hierarchy for that widget. It's not that nested, but probably still not the best for the Unreal. Here we have another panel which is very simple because it has only few widgets and it's a time panel. And this one is implemented entirely in Blueprints. And here we have example of base user widget. It's just some background. We don't care about that much. It doesn't have any logic. It just have few widgets that are properly anchored. They will adjust to the content, and that's all. That's whole mechanic there. So after kind of a year, we are still in this place. So that was a demo after few months of work on Unreal. Let's say gameplay team was unlocked, they could implement their mechanics. Of course, there was still a lot of work for UI, and we were constantly behind the schedule, but it was working quite okay. And one important thing, what was the team composition at that time? So that was 3 years ago. And we had just single UI artist, single UI designer, and single programmer. And that was the whole team behind that. So we are not talking about some very big teams implementing a lot of stuff at the same time. No, it was just me with one UI designer, and our UI artist was mostly just prototyping stuff for later, because as you can see here, it wasn't that much art here. It was very placeholder-ish. So, to move further, we established some basic rules because we made a lot of things not in optimal Unreal way. So we had to control other aspects. First thing, how we approach keeping UI state. Of course, we are not keeping UI state at all. UI should be possible to recreate at any time. We are not holding any information that are very important in the UI. Certainly, we are not serializing to save anything from the UI. UI should be reacting on the gameplay, not the other way around. So we can keep some stuff on the gameplay side. So we have unlocks that are the generic mechanic in the game, and we are using it for some UI features, but not often. And we have separate subsystem to just mark content if it was viewed by player, basically. So if we want to display some yellow star that, hey, you have new content here or not. The most important rule, everything is event-driven. So we are just putting a lot of not beautiful but working nodes that are binding to a lot of events. Our whole game is event-based, and we are not doing almost anything on tick. Of course, sometimes it looks terrible when you have 10 or 15 events in the row. It's very easy to miss something, but in that case, sometimes it's just easier to handle it from the code. So for more complicated widgets, we are just moving it to the code. But first, we are usually implementing it in Blueprints. Let's talk also about UI events that are available in the widgets by default. So first in the flow is called pconstruct. It's called in editor and in the game. It could be called multiple times. It's called on every compile click, on every action, basically. So it's very easy to break something. So for example, if you put spawning widgets there, you can end up with out of memory in the editor. So we just don't use pconstruct. We banned that. We don't need that for anything. Next in the flow is called construct. This will be called few times during the construction flow, so we are using it only for cheap visual-only operations. If you want to change some property of widget, you can do that here, but we still try to avoid that. And the most useful from them, onInitialized, which is called only once and we're using it for binding all events, setting everything from the gameplay. When we are calling on initialized, we are sure that gameplay is already loaded, and we can always get all data from the gameplay. And the last one, event tick, we are just not using it. Of course, we have few exceptions as usual, but as a general rule, we are not ticking widgets. But those widgets were not enough for us. We implemented few more. Starting from the top, we have event initialize editor preview. Previewing stuff in the editor is crucial. So if we are not using preconstruct for that, we are using custom stuff, which is working only in design time. That's basically the only change here. So it's nothing special. It's just logic that is called only in the editor for previewing stuff. We have events for onOpen and onClose. As the name suggests, it's called when we open or close panels, but more generally, when we are switching visibility of panels. So when widgets is started to be visible, or we just hide it. And by the way, we are putting more logic on open than on initialize, because we don't need a lot of logic unless panel is visible. And the last one is something more complicated. We have onWidget close finalizer finished, which is not very beautiful name, but gets the job's done. And it's for onClose animations, because by default in Unreal it's not possible to make onClose animation. When you call animation on hiding panel, it will just hide panel and animation will be stopped, and it's not possible to progress that animation. So we just implemented separate node to call onClose animations, and we are waiting with the real closing of panel to all animation finish, until all animations are finished. Okay, so the next rules, how we are approach error handling. The title of this presentation is "The UI must not fall," but the real rule here is the game must not fall, because we can't crash the game because of the UI. UI is not needed to run the game, and we can never crash the game because of some display problem. We don't have any dependencies from gameplay to UI as a rule, so we are handling everything in the one direction. When we are handling stuff from the UI perspective and getting them from the gameplay, getting data, we have to assume that everyone is trying to deceive us, everyone will put some incorrect data for us, and we assume that all the time we have to validate everything, check everything, and handle every single edge case. Of course, it could be just hide the widget if we don't have correct data. That's the proper handling of stuff. The most important thing is to not make soft blocks, because we, for example, hide the button that is required to progress the game. So here it wouldn't be a good approach to just hide it, but we have to handle every single error. We have to always be ready for edge cases. And at least fail gracefully, so without crashes and without any real problems for the game. Another rule is that keeping all widgets easy to reuse. We are spending a lot of more time on just implementing them, but they are easier to reuse after that. So we are always implementing panels that should be properly anchored. They should adjust size to content. We are quite often make 9 size, so we are just slicing texture to 9 textures, and it helps with scanning panels. So we can just change the size of the panel without visual bugs. And yeah, we are creating a lot of generic assets that we are using later, as I said, and we are trying to encapsulate logic to be able to just copy paste it in another place, but that part is quite difficult. And if we don't do that, we have, for example, this panel, which is very simple. We have some illustration, we have 5 text boxes or something like that, 2 buttons, and it's very easy. And it was that easy that we didn't look at this from the programmer's perspective, and the blueprint for that is contains few hundreds nodes, and we are just adding more nodes there because it's not possible to do anything other with that. So basically, this very long noodle is on open of that panel. Well, a lot of conditions to check, etc. Another very important rule is profiling often. So during development, iteration time is the top priority and easy maintenance for later of that. So we are not doing stuff too optimized, too much optimized, and we are not preemptive optimizing. We prefer to check performance later, find the biggest offenders, and just try to optimize them. Usually just moving some expensive logic to the code. In code, it's much easier to handle logic in an optimal way. And when we are at optimizations, to get away with so many widgets, we are at least trying to optimize it in other areas. So as I said before, we are not ticking widgets. All binds are strictly forbidden because in R you can bind to some variables. We are not doing that because it's on tick. The only exception is for tooltips, because tooltips are handled only on hover of the player, so on a player action, so that's okay. And we are trying to move every heavy logic to user action, not call too much logic in the background. So if player opens the panel, we are putting logic there on open. And we are not recreating whole widgets when updating. We are updating values, we are not deleting widgets and creating new versions of them because it would be easier, but it would be much worse for the performance. And probably the most important rule, it would be doing blueprint reviews. Because blueprints are very easy to prototype, but difficult to maintain. So mandatory reviews of completed features should be implemented. And we don't know what is the finished feature, right? So probably we will review it someday, but it's not today. And we have to be aware of that, because when we are not checking blueprints, they spawn some unspeakable horrors. That was the panel for faction wars. So something very simply displayed 3 text and 1 progress bar, I think. So I had the task to just change some description there. And it wasn't the 5 minutes task how we anticipated. So yeah. And as we talked before, that was the team composition to that point. But in 2022, we finally hired more people. So after that, we still had 1 UI artist, but with support from other artists, so that was okay. We finally had more designers for implementing blueprints, and the most important for me, more UI programmers. So we had 3 UI programmers and a half, and the half is me, because I moved to other topics. I stopped implementing panels manually, basically. And by the way, important thing, we have 0 VFX artists here. So we don't have anyone for strictly UI from the VFX, which probably is the only way to just move some stuff to materials, but we are not doing that often. So I finally had time to move for some custom features. We implemented a lot of things similar to Frostpunk 1, of course, but and we still lacked a lot of widgets that would simplify the work. One of the first one, not implemented by me, but our team, because we had so many people, so there was time finally for implementing basic blocks. We just created dynamic layout, which is the replacement for box layouts and vertical horizontal layouts because they suck in Unreal basically. And we have just single widget for them that could switch between vertical and horizontal. I don't know why it's not the basic Unreal mechanic. And has all configuration per slot. Usually when you use layouts in Unreal, you have to set properties on every slot manually. So if you want to put margins or paddings between elements, you have to do it manually for every single one of them. It should be done on the layout side, of course, so we just do that. We implemented few things for text widgets. So first of all, we are using rich text block for everything, not the simple default one, because we are extensively use tags in texts and icons. So here we have example of one of message panels in our game. Here we have few text styles, different, of course, but after some time, narrative designers decided that they want to change the name of the player. So it was called Steward, but they had the idea that, of course, it would be extremely awesome to start calling player Captain after some action. So we had to make some solution for that. We named that global text tags, and the need was that narrative designers want to change the name which was used in our text 593 times. So the default solution, of course, would be just go to every blueprint where it's used, format it every time, and just do it. Or probably it would be a very terrible week or two of changing blueprints, but it's doable. But it was much easier to create systemic solution for that. So we created PX rich text block, which is our version rich text block. And of course, it was not nice week for UI designers this time to replace existing default ones widgets from Unreal with our new one. But hey, they had to do that. We implemented quite simple solutions. So in blueprints, we have some logic that just put map of tags and display values for them. Here we have only two of them. So based on some policy active in the game, we will just display steward or captain. And the same is for the second one. So we just change currency name based on some unlocks. In the code, it's trivial. We are just passing values from map of those tags to format named arguments that are used for formatting text, and we are just putting single format in the text. Of course, it's not optimal because it will add some overhead, but it's really not that important. We profiled that and we didn't see any problems because we are not setting anything on tick basis. So as long as we are not calling it too often, it's fine. Another feature that we implemented for text was text scale. The need was that the player should be able to change the text scale for mostly for the sake of doing things more accessible. Default solution was just changing text styles. Rich text blocks have text styles that can be changed, but we have 60 of them. And we really didn't want to just put logic in every single place only for switching that. So we came up with systemic solution, or rather I wanted to came up with systemic solution. And here we have example screen with, of course, too big scale that it wouldn't be possible to put it in the game because of something will overlap, etc. But apparently it's already in Unreal, so it was just calling the function which is already in Slate widget for them. So it was just calling set text blocks k on my rich text block. My rich text block is just default Unreal widget in Slate. And it was enough to just find 3 places where I have to call it because then it refreshes, and that's all. That was very easy to implement. I was prepared for a big battle with that feature, but it was too easy, let's say. And here we have 2 screens without and with some big scale, because by the way, it's a very good tool to check if all your widgets are properly anchored, if they will overlap with stuff, if they adjust to size correctly. So here we can see some panels that do that correctly. The one on the center of the screen is not. So we have a problem with that. Probably we should just change that panel and fix it. Okay, so we implemented few custom solutions, but that was only using the new stuff, not editing the engine. And what to do when you hate some engine behavior? I know it's easier to said than done, but just change it. We shouldn't think about the engine as something finished, closed, and optimized, and ready to use in every way, because there is a lot of code that is outdated or not really properly refactored, and in UI it's really common to just see some code from 10 years or even more. One of the simplest examples, when you want to change the visibility of some widget, you will go to the visibility enum, which has, if I remember correctly, 5 or 6 values just for changing the visibility. So we have visible, we have 2 variants of visible, but with some other version of input. We have 2 or 3 versions of not visible, and it's really difficult to remember that, and it's really error prone. And by the way, that's a screen from the internet, because this set visibility now is deprecated in our repo, so I wasn't able to make a screen on our side. And probably it was an error because hidden is not the correct one usually, because it still sits in layout. So it's still calculating, and it's still affecting the performance. So collapsed is the correct one here. So we just make some really small change, and we split that into 4 bools, and that's it. And we are just changing them from blueprints using simple single bool. That was very easy to change in the code, because we didn't change any mechanic at all in code, only some access functions. Another example are retainer boxes. Retainer boxes are great tools to put materials on some UI, on some hierarchy of UI. And then retainer box will render that to the separate render target. So it is expensive but powerful. And those retainer boxes by default are not rendering in the editor, so they're kind of useless. So the first thing that our UI designers ask us, please give us some solution for the editor. There was a lot of talks if we want to write something ours or not, but it turns out that it was very easy to just change it in the code of engine. So it wouldn't be easily achievable without editing the code, but with just few simple lines we enabled that, and it just works. So we added simple property if you want to render it in Designer, and the only real change was just adding checking for that in synchronized properties. And for me, it was just overlook on the Epic side, or probably there were problems with some crashes, so they decided that, okay, we'll disable the feature and we don't have a problem. So yeah. So instead looking like this, it will just mask everything in the editor, because we are using return boxes mostly for masks. Okay, so we introduced a lot of changes in the engine, in our code base. What about further development? We upgraded to Unreal 5 only at the end of 2022 because we were really not sure if it will be stable enough. So that was our approach, to just upgrade it after a few patches, and it gave us even darker editor interface, and for UMG almost nothing. So it was important for the rest of the game, but not for the UI, basically. It added common UI, which is nice library of widget, but they were crashing at that point quite often. So that was the state after implementing all those features. There were a lot of iterations on that. Later we switched to Unreal 5.2. We skipped 5.1. So merging that was a hell, but fortunately not mine. And still not much for UMG. They added enhanced input. It's nice tool for combining multiple shortcuts into contexts, and we use them with our contexts. So there was a lot of iterations and more iterations, and everything we did in the representative placeholder approach. So everything was almost in final quality. So we had so many iterations that it cost us a lot of work. Here we have after another and another iteration. That's from the 2023 end of the year. So it was probably time to move to the release phase at some point. It was planned for March this year, but we see that it really wasn't achievable. With every day we see that, okay, we still have so many mechanics that it wasn't possible. So fortunately it was delayed. Unfortunately, after a few days, it was announced that we'll make a public beta version. So we didn't have more time. We have even less, because we had to prepare for even shorter launch window for us. So we, of course, delivered that in some quality. It wasn't ideal. It was okay, but after that we had quite a lot of feedback from players that they want dark mode. So let's talk about implementing dark mode. Dark mode was implemented before the beta, but they didn't see that because it was activated only on some game logic when in your city there are so many problems that the tension is high, etc. So first of all, when we get the request to implement dark mode, it was only for district panel. Only one panel, we don't need to make any systemic solutions, that's fine. That was a trap, of course. And we ignored that, ignored request that, okay, it's only for one panel, we just did systemic solution for everything from the start, because we were sure that it will be used later. So we had to implement our own image widget because we didn't think about that. And as you saw earlier, we have 32,000 images at the same time. So there were probably a few thousand widgets to replace by our UI designers, but they had to do that. because we forgot to create base widgets at the start. So basically, we just created another subsystem for handling that, which behaves in almost component subsystem way, because we just added some events to call on construct, deconstruct image, and we are handling it in very similar way. We added to every single image those color modes, so it could be static color or data asset with color, and we are just switching between color asset and dark mode color asset. And PX panels are responsive for handling that for the whole hierarchy. So every panel knows if it's in dark mode or not, and you can just override the function to decide what is the logic behind that. So we are switching colors instantly, and it was fine. For the beta, it was fine. We covered that transition with some animation, and it was looking, for me, quite okay. Everyone was happy. Well, almost, because apparently art-wise it wasn't good enough, so we had to refactor it. Before the release, exactly 3 days before the release, there was a decision, okay, that's the very important feature, and we have to push it. So we pushed it with success, almost, because next day I get a report like that with 100 milliseconds on tick from gameplay, and we just called that too many times. So yeah, feature was delivered, but performance was very, very bad. Of course, it wasn't every tick, but there were so many spikes that it was really bad. So Daisy's solution, just add dirty flags. So instead of updating it every time, just set the flag, and on tick, that's the exception where we can use tick, and just check it and make that update max 1 time per frame. And we added mighty optimization. We moved the logic from blueprint to code, and we just add this early return because we didn't block that later, so it was updating every frame instead of, for example, when tension changed only, when dark mode should change. So yeah, that's, I will skip loading screens because we don't have much time left. And yeah, we released that. That's the end of the problem. So we released that with some earlier access, proper release, and that's the state from the release date. And yeah, we are still implementing a lot of patches. So for me, it's too early to call it that we finished release. So I'm still in the development phase. So I'm not able to say more about that state. Thank you.